What's that? You've never taken a derivative before. In a few minutes, I'm going to show you a few examples, 4 examples to be specific, of basic rules of differentiation. Specifically, we're going to be looking at the power rule today. If we're just meeting, my name's Mark Nolde. I've been teaching high school and college math for over 20 years now. That includes my 4 daughters. So let's get to it. So let's look at a couple of examples of the basic rules of derivatives. We'll start with a simple polynomial function that just uses the power rule. So to take the derivative of this function, remember we multiply exponent times coefficient, so that gives negative 6x, and this exponent of 2 gets reduced to a 1. So 1 is understood, so I don't have to write it there. Looking over at the next term, here's a 1 and here's a 2. So 1 times 2, well, that's just a 2. And I don't write this. 0 is 1 less than 1, but x to the 0 is just 1, so we don't write this typically. So I'll erase that. So there, friends, is the first derivative of the polynomial function negative 3x squared plus 2x minus 4. So I always tell my students not to lose sight of the fact that a derivative is a slope. So some of the problems we're going to look at are going to say, find the equation of a tangent line to this function at this point. These are contrived problems, so they should work out. But we can verify that this point is on this function, 1. Let's see, negative 2 times 1 is negative 2. 5 times 1 is 5. Negative 2 and 5 is 3. 3 minus 3 is 0. All right, so that's on the function. So the first thing to do in this problem, I guess we'll stick with the pink, would be to take the derivative of f. So f prime of x equals negative 8x cubed plus 10x, and the negative 3 goes to 0. So again, if you're just learning this, 4 times negative 2 is the negative 8. 4 gets reduced by 1 to a 3. 2 times 5 is 10. And this exponent of 2 gets reduced to a 1. So now I have a derivative. So this is a formula that tells me the slope of a tangent line any place on this function. So I know a point, so I'm going to plug in a 1 and say, f prime at 1 equals negative 8 times 1 cubed plus 10 times 1. So that equals, let's see, negative 8 and 10 would be 2. So I'm looking at a slope of 2. So now we're back in algebra days here, right? When you know the slope of a function or the slope of a line and a point that's on the line, you can use the point slope formula to come up with that line. So that's what we're looking for here, is the tangent line. So let me switch colors quick. So y minus y sub 1 equals the slope times x minus x sub 1. This was our point slope form. So if we know a point, and we do, and we know the slope, and we do, we just figured it out with the derivative, we can go ahead and substitute. So y minus 0, where's that 0 coming from? This 0 is coming from this 0. And that is equal to the slope. What's my slope? 2. I just figured it out here. So in place of m, I'm going to put 2. And then I'm going to go and get the x-coordinate. So the x-coordinate of the given point happens to be 1. So I'm going to put a 1 here. So 1. And that, sports fans, is a good enough answer in my book. That's a line. Some students might think they have to simplify it. Maybe I would get rid of that 0. This would actually be pretty easy to simplify this way as well. But this is a line the same as this is a line. This line, let me use my pointer, this line just happens to be in slope-intercept form. This line is in point-slope form. But these two lines are equivalent. They mean the same thing. So it's okay to leave it like this, unless the directions, which they didn't say to write it in slope-intercept form. Okay? So next. So this next one might look a little bit trickier than it really is, because why? It's got a trig function with it. But we learned earlier, when you learned basic differentiation, you learned that the derivative of sine is cosine, and the derivative of cosine is negative sine. So we're going to go through and we're going to differentiate this term by term. And then we're going to find the slope of the graph. So we don't have to find a point. We're just looking for the slope of the graph at this point. So let's go ahead and do that. First derivative. So theta is it's just not an x, it's a theta. That can be confusing sometimes. But this theta, that's the same as saying f of x. It's 4 sine x minus x. So in any event, we're going to go and say this is 4 cosine theta. And we know that this is just a constant. Whoops. So I drew another theta. So that goes to 0. So that's not even going to be there. So now I'm going to take this point that's given. X is, or the first, this is theta and f of theta. So theta is 0. So we're going to find f prime of 0. Well, that equals 4 times the cosine of 0. And the cosine of 0, we learned in pre-calc, is 1. So this is just 4 times 1, or plain old 4. So the slope, remember, the derivative is a slope. So the slope of this curve at this point is 4. And that's what that tells us. Okay, great job. Thank you for watching to the end. I do appreciate it. Make sure you smash that like button and even subscribe. Help my subscriber count. I would appreciate that. So anyway, just remember, math is not a spectator sport. You have to pay attention, you have to do the work, and most importantly, you have to not give up. So until next time.